Good morning, students. May I request everyone to please stand, and I will choose one student here in my class record to lead the prayer. Okay? May I call on Mr. Advincula? Please lead the prayer. Amen. Okay, students, for those who did not know me yet, I am Birang Emmanuel E., your today's M109 instructor. Are you ready to our first lesson? Okay, before we proceed to our main objectives, I will give you a short activity first. I have pictures here, and you need to name every pics, then combine it together in order to get the name of one of the Greek mathematicians. Okay, well done. It is Apple plus loan plus news is equals to Apollonius. Very good. We will tackle him today about Apollonius problem. Now, here's our main objectives for today's discussion about the topic. At the end of the lesson, the students will able to know who is Apollonius, what is Apollonius' famous problem, and how can we construct another circle that is tangent to all three circles. Who is Apollonius? Anyone in the class? Okay, Mr. Advincula again. Very well said. Apollonius was a Greek mathematician known as the Great Geometer. His works had a very great influence on the development of mathematics, and his famous book, Conics, introduced the terms parabola, ellipse, and hyperbola. More than 2,000 years ago, Apollonius proposed this famous problem given by three circles. How can we construct another circle that is tangent to all three them? To Apollonius, there are only a couple of tools we can use: a straight edge and a compass. A straight edge is like a ruler, but without any markings on it. So together with a pencil, we can draw straight lines but not measure any distances. A compass, on the other hand, allows you to draw a circle. This problem of Apollonius looks easy, but you can try it and see that it is a trivial geometry problem. In fact, we will have to simplification first. We want to only consider the case where the circles are in a so-called generic configuration, which means there are no intersection between any two circles and their interiors don't overlap. The other cases can be harder to tackle, and sometimes there isn't even solution. Apollonius himself actually solved this problem, but his works were lost. But because this is such a famous problem, mathematicians develop different solutions to the problem. This solution starts off with a powerful tool in Euclidean geometry called circle inversions. Suppose you have a circle, then you want to invert this blue point with respect to the circle, then you will get another point. This point is not arbitrary, and it fulfills two properties. Firstly, the image A has to lie on the ray from the center to A. Only the product of the distance from center is the radius squared. If you invert a point twice the respect to the same circle, you get the same point back. This is because this property still holds, and so A is the inversion point of A prime. One other thing to note is that inversion of a point can be done with straight edge and compasses. If you are wondering, here is one way to the construction. We first draw a perpendicular from A to meet a circle at B, then draw a tangent to the circle at B. Before we end, I have an activity. You need to answer this question. You have 5 minutes to answer. All done? Pass your paper. Okay, class, you need to advance study for our next topic about the shoemaker's knife. Goodbye, students. See you again next time. Have a great day.